Hello, hello. So good evening, students. I hope you all are doing well. और हम आते हैं अपने टॉपिक पे। तो अभी तक हमारा जो कल का डिस्कशन था, कल तक का डिस्कशन हमारा था concentration term. And in concentration term, what are the things that we have discussed yesterday? The things were, so can concentration be expressed in one way, two way, or many way? So we all know that the concentration can be expressed in many ways. Okay, and if we say many ways, so what are these? So the most commonly expressed terms are mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molarity, molality, normality. Okay, then we have formality. So formality we rarely discuss. But if we talk about mole fraction, it's very common, very easy, but calculation is bit difficult. Okay, so mass percentage, volume by volume percentage, parts per million, and mole fraction. All these concentration terms we have discussed. All right. Now we have to discuss this done. This is also done. This is also done. This is also done. This is also done. Now we are left with main three: molarity, molality, and normality, which is expected to be asked in examinations. Okay, so let us start with this then. So let us start with the solution again. And our today's topic is what? Our today's topic is molarity. So if we talk about molarity, so this molarity is the most commonly used unit in order to prepare any solution. So what is this molarity? So it is denoted by capital M. Remember, denoted by capital M. Definition: so the number of moles of solute. Remember, number of moles of solute that is dissolved in per liter of the solution. We call it as molarity. So formula is M equals to N upon V. This is the general formula that we use where N is number of moles. And how we can calculate this number of moles? So in order to calculate this number of moles, what we do, it's very important to note. Okay, this is very important to note here. And what is this? And this is unit. It's very important to note unit. So unit of molarity is moles per liter. Okay, moles per liter. याद रखना है. Okay. Now further, how to like derive this formula, because it's not always that the number of moles will be given to you. Sometimes mass or weight of substance is also given. So molarity, weight of the solute upon the molar mass or gram molecular weight of the solute into 1000 upon volume in liters. Or the same formula can be written as W upon gram molecular weight into 1000 upon V in ml. Okay, so this is the formula that we use for the calculation of numericals, and the formula is this. Okay, as I told you, okay, as I told you, number of moles is not always given here. So weight of the solute equals to m into gmw into v upon 1000. And when we use this formula, like in order to prepare solution for preparation of solution, suppose it is given to us कि हमें एक specific concentration का एक solution बनाना है, so in that case we can use this formula. अब मैंने आपको बोल दिया कि 1 molar बनाना है आपको NaOH solution और कितना होना चाहिए, you have to make it 200 ml only. So what you will do here, you will find out this weight of the solute. So simply m will become 1 gram molecular weight is 40 only. V is already given, that is 200 ml. सारी values को put करने पे हमें यहाँ से मिल जाता है 30. So how much we need to take? We need to take 8 grams, 8 grams of NaOH in 200 ml of water. For dilution process, what we do, we use this formula. In this formula, we call it as molarity formula. M1V1 equals to M2V2. बहुत important है, especially JEE and NEET के लिए. For neutralization reaction, what we do, M1V1 upon N1 equals to M2V2 upon N2. Okay, so this is for neutralization process. For mixed solution, we sum M1V1 plus M2V2, okay, divided by V1 plus V2 plus and so on. Okay, this is one another process. Okay, number of moles of solute equals to molarity into volume of solution in the liters, or number of moles equals to what, M into V. Number of millimoles of solute equals to what, molarity into volume of solution in ml. Molarity is inversely proportional to volume. And what does it mean? If it is inversely proportional to volume, it means molarity depends molarity depends upon temperature. Because when temperature is changed, okay, when temperature is changed, what happens, volume also changes. So molarity depends on temperature. Okay, molarity changes with temperature because volume depends on temperature. With rise in temperature, volume increases, and what will happen, with fall in temperature, volume decreases. So when temperature is increased, concentration decreases because volume is increasing. With increase in temperature, molarity decreases, and with decrease in temperature, molarity increases. Very important, especially for multiple choice question. This is something very important that you need to know. With increase in temperature, we already discussed. Now, important points. These are the terms that we use, not always, but many a times we use this formula. Okay, so what it is? Decimolar. Decimolar means 0.1 molar. Okay, then we have then we have next centimolar. So centimolar is what? Centimolar is 0.01 molar. Millimolar, so millimolar we all know it will be 0.001 molar. Then we have semimolar. Semimolar we all know 0.5 molar. Decamolar means 10 molar. Then we have questions. Will the molarity of a solution at 500 degrees Celsius be same, less or more than molarity at 25 degree Celsius? So what we discussed that with increase in temperature, molarity decreases. So let us check. Molarity at 50 degree Celsius of a solution will be less than at 25 degrees Celsius because molarity decreases with temperature. Next is question, what is meant by 0 what is meant by 1.0 molar NaOH? So here 1 mole means 40 gram NaOH on dissolution in water to make a liter solution is called 1.0 molar. It's very simple. 1 molar means 1 mole of that particular solute is dissolved in per liter of the solution. What happens to the molarity of solution if the solution is heated? Again, molarity decreases. Okay, molarity decreases due to raise in temperature. Which of the following are correct statement? So here M is inversely proportional to V, M is inversely proportional to T, M is directly proportional to T, both A and B. So which will be the correct options here? Both A and B. Normality. So if we talk about normality, so this normality term, okay, this normality term is not there in CBSE, especially for theory paper. But sometimes it is used in practicals. So what is this normality? If we talk about normality, so first of all we need to know about equivalent weight. So equivalent weight of a substance is expressed in grams and is known as gram equivalent weight or gram equivalent or equivalent simply. So the weight of the substance that combines or displaces with this is what this is the standard definition. So what it is, the weight of substance that combines or displaces with 1.008 grams of hydrogen or 8 grams of oxygen or 35.5 gram of chlorine. That weight of the substance we call it as equivalent weight. Equivalent weight of an element can be easily calculated. Equivalent weight of hydrogen is what? Weight of the element upon weight of hydrogen into 1.008. Equivalent weight of oxygen. So in that case, what we do, weight of element upon volume of hydrogen at STP in ml and then 1120. Remember, this we are talking for an element. Number of gram equivalents, weight of the substance in grams. Okay, weight of the substance in grams. So it should be like this, weight of substance in grams upon equivalent weight. So this gives us what? This gives us number of gram equivalent. Equivalent weight of an acid. This is the formula that we have to use. So it is molecular weight upon basicity, because we discuss basicity term for acids and acidity term for bases. So number of replaceable hydrogen ion of acid is called basicity. So in case of HCl, so we have 36.5. In case of H2SO4, we have 92, because here we have number of replaceable hydrogen as 2. We have E equals to H3PO3. Here again we have to calculate equivalent weight, and here number of replaceable H is 3. So accordingly we are dividing here molecular molecular weight by number of replaceable H or by the basicity. After this, in each cases we have number of replaceable H, equivalent weight of bases. So bases, in cases bases we use acidic term like number of replaceable hydroxyl group. So BaOH twice to number of replaceable OH ion is 2. So molecular mass or molecular weight will be divided by 2. Then we have NaOH. In case of NaOH, it is divided by 1. In case of FeOH thrice, we have M by 3. Then equivalent weight of salt. So equivalent weight of salt is what? Formula weight of the salt upon total charge of the cation or anion of the salt present. So this is the formula which we it's least used. Example, potassium dichromate K2Cr2O7 is there, and we all know this can also be written as K plus Cr2O7 2 negative, right? So the same thing we'll do here also. So how many electrons it gains? It gains 6 electrons and it changes into Cr3 plus. So in that case, what's the change in oxidation number? So here change in oxidation number is from, yes. So the change in oxidation number is how much? The equivalent mass. In order to calculate the equivalent mass, we will what? Will divide the molar mass, sorry, molecular weight by change in oxidation number. So change in oxidation number is how much? 6. Okay. So for one chromium atom it is 3, change in oxidation number. For two chromium atom is 6, so number of electrons gained is 6. So here it will be divided by 6. So formula mass will be divided by 6. So here we have equivalent weight as 49. Then we have equivalent weight of reducing agent. So in case of reducing agent means the one which undergoes oxidation. So more salt, FeSO4, NH4 twice SO4, 6H2O. Formula weight is 392. So how many electrons it loses? 1. So simply here equivalent mass will be 392. Na2 sodium thiosulfate, when it reacts with iodine, then it changes into Na2S4O3. And what is the change in oxidation number or number of electrons lost or gained? H2 positive changes into H positive and it loses one electron. Okay, I guess it's somehow written. Uh, yes, here it should be plus. Okay, so what's the thing that we have to do is divided by 1. EW of a compound in a disproportionation reaction. Disproportionation reactions are those in which the same species undergoes oxidation as well as reduction. Okay, so here we have, like P4 undergoes disproportionation reaction in basic medium to give PH3 phosphine and H2PO2 dihydrogen hypophosphite ion. Atomic weight is of P is 31. So how we can do this? P4 changes into H2PO2 negative plus 4 electron. So here N is what? 4 electron. So the number of electrons lost is 4. So simply what we'll do? We'll divide it by, this is the formula. In one case it undergoes oxidation, in another case it undergoes reduction. So simply molecular weight of P4 plus 4 MW P4 upon 4 plus MW P4 upon 12. So this will give us what? This will give us the equivalent mass. Normality. So what is this normality? Normality is the number of gram equivalent. Remember, number of gram equivalent of a solute present in 1 liter of the solution. Normal solution contains 1 gram equivalent of solute in 1 liter of the solution. A decinormal solution is n by 10 or 0.1. Same prefix we are using that we have used for molarity. Then normality, weight of solute in grams into 1000 upon gram equivalent weight into volume in ml. And this is the normality formula. And if we just want to simplify it more, so what we can do here, uh, like normality, capital N equals to equivalent mass upon, okay, so here just a small correction. So here what we'll do, number of gram equivalents we have to find out first. So number of gram equivalent, how we can find out? Weight upon equivalent mass or upon V if it is written in ml and divided by 1000. So this 1000 will come here. So the above formula can be written as W into 1000 upon equivalent mass into V in ml. And this is for what? This is for normality. And when we have to prepare any solution, then the same formula becomes N E V upon 1000. So this is the formula that we use. Okay. Again, I'm writing here because of my image, it's not visible. So I'm just writing here. So W equals to N E V upon 1000. Okay. So this is the generalized formula for normality. Then we have molarity. So what is this molarity? अभी तक हमने जितना भी डिस्कशन किया उन सारे डिस्कशन हम सॉल्यूशन की बात कर रहे थे बट दिस टाइम वी आर टॉकिंग अबाउट द सॉल्वेंट. Okay, so it is defined as, it is denoted by small m, the number of moles of the solute present in 1 kg of the solvent or 1000 grams of the solvent is called molality. So formula molality is number of moles of the solute divided by mass of the solvent. Okay. So unit is mole per kg. अभी तक हमने क्या डिस्कस किया था in molarity? It was moles per liter. So here we have moles per kg. The same formula can be written as molality is independent on temperature because the mass does not change with temperature. Mass remains constant. Okay. So here, so it is the most common and convenient method to express the concentration of the solution. Then formula related to molality. It's very important. Molality, so number of moles of the solute upon mass of solvent in kg. Then molality, weight of the solute in grams upon gram molecular weight of solute 1000 divided by weight of solvent in grams. Question: does molality change with temperature and why? No, molality doesn't change because here we consider mass, not volume. That's why. Because the mass does not change with the temperature. Why is 1 molar aqueous solution is more concentrated than 1 molar? So students, when we are saying 1 molar, so 1 molar means 1 moles of solute, 1 moles of solute is present in 1 liter of the solution. And when we say 1 molar means 1 mole of solute is present in per kg of the solvent. Remember, per kg of the solvent. So here 1 molar aqueous solution means 1 mole of solute in 1000 ml of the solution. Whereas 1 molar aqueous solution is 1 mole of solute in 1 kg of solvent. And here we convert kg 1 kg of water into volume, so it will be less. So a solution of glucose in water is labeled as 10% W by W. What would be molality of the solution? So here mass of glucose we all know 10 gram, mass of solution is 100 and mass of water will be what? Mass of water will be 100 minus 10 equals to 90 grams. So we can easily calculate this molality. Okay? So simply number of moles, molality of solution, mass of glucose upon gram molecular weight of glucose, then mass of solvent. Molality of solution is 10 180 1 upon 0.09. So on solving this will be getting 0.617 moles per kg or molar simply. This is the equation that we'll be getting here. Calculate the molarity of solution containing 5 gram of NaOH in 450 ml solution. Very easy question. So number of moles of NaOH. So how we can find out? 5 gram divided by 40. Then this is 0.125. Then we have volume of the solution in liters. So 450 will be turned into liters. So 450,000 into 1000. So it becomes 0.45 liters. Using equation, molarity, number of moles of solute upon number of moles of the solute upon volume of the solution in liters. So 0.125 upon 0.45, and this is 0.278 molar, and this is what is the final answer. Calculate the molarity of 2.5 gram of ethanoic acid in 75 gram of benzene. We have to calculate molality. So we can easily calculate this. Molecular weight of ethanoic acid is 60. Weight of ethanoic acid given is 2.5. So we can calculate the number of moles easily. Mass of benzene, weight of benzene is 75 grams. Molality is weight of solute upon molecular weight of solute, 1000 upon weight of solvent in grams. So it is 2.5, 60,000 weight of solvent in grams and divided by 75. So this will give us 0.556 molar. And this type of questions are very important and very easy. The thing is we have to be very good in calculation. Important points regarding concentration. This is very important, and let's see. 1 by m. D stands for density, m stands for molarity, gmw of solute upon 1000. This is the relation between molarity and molality. Okay, so this can be further changed like this. Okay, so any one relation we need to remember. Mp is molecular weight of solute. Any one we need to remember. Okay, relation between molality and mole fraction. This is something that's very important, and also it's there in NCRT. So chi b upon chi a equals to Na upon Nb. This we can say. Or chi a can be written as 1 minus chi b, Wb upon Mb into Ma upon Wa, or the same can be written as like this. So basically what we have to do, we have to calculate molality and mole fraction. This is, if you can remember, then it's well and good. Otherwise just go for the derivation thing. Okay, so chi b upon 1 minus chi b equals to molality into Ma, where Ma is what? Ma is molar mass upon 1000. Relation between molarity and normality, it's very easy. Molarity into GMW equals to normality into gram equivalent weight. So important points to remember. Mass percentage is used in industrial applications. Mole fraction unit is very useful in relating some physical properties of solutions, say vapor pressure, and quite useful in describing calculations involving gas mixtures. Then at 35.5 degree volume by volume solution of ethylene glycol, an antifreeze is used in car for cooling engine. We all know, पुरानी मूवीज में जाते हैं ना, ले आने और वहीं पे आ जाते हैं सब मेहमान लोग. It lowers the freezing point of water from 0 degrees Celsius to minus 17 degrees Celsius. Commercial bleaching solution contains 3.62 mass percentage of sodium hypochlorite. Mass percentage, parts per million, mole fraction and molality do not change with temperature. Always remember this MCQ we can have from this topic. Only molarity changes with temperature and normality. Remember, normality also changes with temperature. Normality also. Which is independent of temperature. Very important question. Very important. Mass percentage, mole fraction, parts per million, all of the above. So answer is all. That's all. So students, we are done with this. We are done with this part, that is concentration term. Few more numericals we'll discuss. In case if you have any doubt, तो आप कमेंट सेक्शन में भी बता सकते हैं। एंड ऑल्सो आई विल शेयर इन द चैट बॉक्स, टेलीग्राम चैनल का मैं आपको लिंक शेयर कर दूंगा। इवन यू कैन पोस्ट योर क्वेश्चंस देयर ऑल्सो। मोल फ्रैक्शन, मोलैरिटी, ये दो ऐसे टर्म हैं जिनके न्यूमेरिकल्स इजी हैं, बट इट इन्वॉल्व्स वेरी गुड कैलकुलेशन। तो कैलकुलेशन में हमें बहुत अच्छा होना पड़ेगा। दैट्स ऑल फॉर टुडे। थैंक यू वेरी मच। हैव अ गुड डे।